Hi folks, I thought we'd take a look today at the floppy and hard drive controller from a 186 RM Nimbus. This one is taken from one of my machines that already has a hard drive fitted. The hard drive fitted is a 50-pin SCSI drive. The Nimbus has a limited selection of drives that it can accept. One of them being the Connor CP3040. This one's been taken from an old Apple computer that I had lying around. It should work. So it's a 50-pin SCSI. You need to make up a cable that goes from the 50-pin to the 34, and this is one here. It's fairly straightforward, as you can see. It seems to be just kind of split down the middle, 50-50, half down one side, half down the other. Now, on the Nimbuses that didn't have a hard drive fitted, they had pretty much the same board, but minus the components necessary to control the hard drive. So I'm thinking it should just be a straightforward process of adding the missing components and connecting it up. One thing that I did look at was other versions of the board. As you can see, this one is the same version number exactly. Part number 23731, issue 1. I do have other Nimbuses that take different boards. This, for example, is an earlier board. It's actually a nicer finish, this one. The glass board is a lot better quality. But unfortunately, there are differences that worry me in terms of just adding components without any documentation. For example, if we compare the two boards, you'll see that down here on the populated board there's a section with just links in it, whereas on the earlier board there's actually space for an IC. So that's the first concern. The other one is that you can see up here they've added a voltage regulator, where according to the legend on the board, if you can see that, it should be a capacitor, but what they've actually done is added in, as I say, the 5-volt regulator. On the later board they've added a proper regulator. Going back to the earlier board, there are some changes that they've made post-production. For example, you can see a cut in one of the tracks here. If I can get the thing to focus. There was a cut somewhere else as well, if I recall. Get rid of those. You can also see that they've added this trace post-production. Made a cut here. Tracing the connections, there are some differences between the connections to various chips on this board than there are to the populated one. My worry is that this particular board, having been manufactured and decided to be used as just a floppy controller, they've then made changes to the board which are only suitable for when it's in use as a floppy controller. So I'm a little bit reluctant to add what are probably the same components to this board as are on the fully populated one. I think, given the choice, I will simply upgrade this one, which is exactly the same but it's just missing the various components. It might be something I do at a later point, but for this test I'm going to upgrade this one. I managed to locate all the various components apart from the resistor network on this one here, which I'm probably going to just build up using discrete components rather as an all-in-one IC. So as you can see on the board, the missing component sockets all have solder in them. So I'm going to be using a desoldering tool to clear those out and then populate the missing components. I do recommend that if anybody's going to try this, you get hold of a desoldering pump. You can pick them up relatively cheaply on Amazon. This is the one that I'll be using. This is a Dura tool. I must admit it didn't last very long. I think it broke within a few minutes of using it. This connection here cracked. It was a terrible design really, but I've just epoxied that back together, and it's been fine ever since. And considering it was only about £60 in the UK, I don't think I can complain too much. But it's absolutely marvellous. It really does the trick. So get yourself one of these if you're going to try it.